This is the second video reviewing the concepts and skills getting ready for our summative on Tuesday. At the beginning of the first video, we went over all of the formulas for surface area and volume, and I've just taken a copy of those notes and put them at the top of this whiteboard as well. Remember that the whiteboards are also available to you using the link on the first page of the Google Slides. So we talked about prisms and pyramids on the last video. Now we're moving on to the surface area of cylinders, spheres, and cones, surface area and volume. So not as many people had questions about the surface area of cylinders, so I'm going to go over these pretty quickly. When I'm looking at the surface area of cylinders, there were actually 4 problems on the practice summative having to do with that. So problems number 5 and 6 were pretty straightforward. I know, again, that the surface area of a cylinder is going to be the area of its base times 2, plus the lateral surface area, which is going to be the circumference of the base times the height. So notice that I started off writing kind of the idea of it, and then I specifically wrote the formula, and then I started plugging in the numbers. And I did the same thing on problem number 6 right next to it. Notice that as I'm doing this multiplication, I did not multiply times 3.14 until I got all the way to the end. So I kept things in terms of pi until I had 540 pi, and then I multiplied times 3.14, and I found my answer for number 5, and then I found the answer for number 6. On problem number 7, it asks just for the lateral surface area, so I don't need the area of the bottom and the top. I just need the area of that rectangular lateral face, so that's going to be the circumference of my circle times the height. This one was tricky only because it has fractions involved in decimals. I think actually they were both, I think this was written as 7.5. You may remember, you should remember that 5/8 is 0.625, but if you didn't remember that and you forget how to put fractions into a calculator, or you're ever working with a calculator that doesn't have a fraction key, remember that this is a division problem, so you could do 5 divided by 8 and find 0.625, add 6, and then multiply times pi, and then multiply times 7.5. So that answer is 156.02 inches squared, and this one did ask me to round to the nearest hundredth. These two asked me to round to the nearest tenth. Number 10 is probably the trickiest of the surface area of the cylinder questions. So I don't have that all written out. We'll do that one together. So this was a composite figure, and it had basically a big cylinder and then a small cylinder on top of it. So I'm going to start by finding the surface area of the big cylinder. So I know that that's going to be 2 times the area of my base, plus my circumference times the height. So I'm going to start filling in those numbers. The radius on this one was 10, so I've got 10 squared times 2 pi. And then, again, my radius was 10. And it would be fine for you to just put the diameter in there and write it as 20, but I actually remember the formula as 2 times the radius instead of just the diameter. Some of you might just go straight to the diameter in your head. And then the height of that cylinder is times 2. So finishing that up on the calculator, I find that the surface area of the big cylinder is 240 pi. Notice that I haven't made any adjustments yet for the fact that I don't have the entire top of that, but I'll make that adjustment coming up. So then I'm going to find the surface area of the small cylinder. So I'm going to use exactly the same formula. So I've got 2 pi, and the radius of that one is 5, so that's times 25, plus 2 times 5 times pi times 2. And you might be saying to yourself, well, wait a minute, they're stacked on top of each other. I'll adjust for that in a minute. So I'm going to quickly do that calculation. So the surface area of the small cylinder is 70 pi. And these two are stacked on top of each other, so we might think that we need to just add them together. But when we add them together, we cover up the surface of the bottom of the small one isn't there, and then the top of the bottom one equal to this size isn't there. So that actually takes out 2 of the area of the smaller cylinder. So this whole thing is going to not be included. So you might say, well, why did you even include it in the first place? I didn't have to, and I just want to make it visible to everyone, like that we're finding the 2, we're adding them together, and then we're compensating for the fact that we actually don't have the full surface area. So you might choose to just leave that out in the first place, and that's fine. So I'm actually going to add 240 pi plus 20 pi, because all I really want is that part, and so that's going to give me the 260 pi, which is 816.4 feet squared. So the volume of cylinders problems are number 15 and 16 on your practice summative. So again, volume, pretty easy with a cylinder. I'm going to find the area of the base and multiply it times the height. So you can pause the video here and look at number 15 and 16 if you need to go over those problems. Next up, we have a couple problems dealing with the volume of cones. They're number 17 and 18. So again, when I'm looking at the volume of a cone, I'm going to find the volume of the cylinder. So the area of the base times the height. But because it's a cone, I'm going to multiply times 1/3. So I've got pi r squared times h times 1/3. And in this problem, the radius is 6, the height is 7. I've got pi. So I'll come back and do that calculation in just a minute. On problem number 18, I also have a cone. So my volume is going to be the same thing, but it gives me the diameter. So I need to, I'm going to use the radius, which is half of that. So I've got pi times the radius squared, which is going to be 36, times the height, which is 4, times 1/3, because it is a cone. So I know I've written this in a little weird way because it looks weird to have the 36 after the pi, but that's okay because I'm showing my work and now I'm going to go back and do that calculation. So for 17, I get 263.8 inches cubed. For 18, I have 150.7 millimeters cubed. Those problems both set to round to the nearest tenth. Interestingly, my answer key has different rounding on both of these. But I double checked this and I think this rounding is accurate. I am not going to be picky about the rounding. I am going to have you do the test on Clever. And so it might be picky about the rounding, and I will go back and look at each one of them that you miss so that I can make sure that it's not a rounding mistake. So I will go through and adjust those. Finally, I then have the volume of a couple of spheres. So again, what we've learned is that the volume of the sphere is 2/3 times the volume of the cylinder. So the volume of the cylinder is going to be pi r squared times the height. And the height is going to be 2 times the radius. So I'm going to end up with 2/3 times pi r squared times 2 times the radius, which is 4/3 pi r cubed. So I'm going to use that on problem number 19, which is 4/3 times pi times 4.2 cubed. And then on problem number 20, it's going to be 4/3 times pi times 3.4, which is half of the diameter cubed. So when I do that calculation on my calculator on number 19, I'm going to get 310.2 feet cubed. Number 20 is 164.6 feet cubed. Next, I'm going to go back and do a couple of the oddball problems that might mix together some skills. So I'm going back to problem number 12, which is about the volume of a pyramid. So it tells me that the volume of a pyramid is 84 cubic feet. And I know that the volume of a pyramid is going to be the volume of the rectangular prism times 1/3. So it's going to be 1/3 times volume of the prism. And then it tells me that the area of the base is 21. And I need the height. So that's the part I don't know. So it's going to be 21 times h times 1/3 equals 84. So I'm solving basically for h. Sorry, this was supposed to be a 1/3, and it sometimes auto corrects it and makes it into a shape. So I'm going to do 84 equals 7h, divide both sides by 7, and the height of that pyramid is 12 feet. On number 13, it asks what happens to the volume of a rectangular prism when the length and width are doubled and the height is tripled. So my original rectangular prism, I've got my length times my width times my height. The new one is going to be, the length is doubled, so it's going to be 2 times L. The width is doubled, so it's going to be 2 times W, and the height is tripled, so it's going to be 3 times H. This is all being multiplied, so I can multiply these coefficients together. So I get 2 times 2 is 4, times 3 is 12. So the whole thing is 12 times bigger. This is what the volume is 12 times larger. And then the other kind of oddball problem related to volume of prisms is number 14. It asks, it says that the solids have the same volume. What is the height of the pyramid? So I know that those solids, the volume is equal. And the volume of the rectangular prism is going to be x times x, or x squared times y. And the volume of the triangular pyramid is going to be 1/3 times the base, x squared, times the height, which is what we're trying to find. So I write an equation with all of that, and then I'm going to solve my equation. I can divide both sides by x squared. So I end up with y equals 1/3 times the height. And I want to know what the height is, so I'm going to multiply both sides times 3. So I find that the height is equal to 3 times y. And then finally, the last problems on this practice summative were actually problems that we did not do a lesson on. So this will be a quick lesson. It is about similar solids. And we had done something related to this in our previous unit. So I think that this will come to you pretty quickly. And keep in mind that we had not done it prior to your practice summative, so I understand if these problems were difficult for you. On problems number 21 and 22, we're basically finding if they're similar. So one of the things that we know about similar shapes is that their sides are proportional. Similar solids are the same thing, so they have to be the same basic shape, and their sides have to be proportional. So on number 21, I have a scale factor from the small one to the big one, about one side that's being multiplied times 2, a second side that's being multiplied times 2, but then the third side is not being multiplied times 2, so that one was no. Again, I'm just looking at all of the different dimensions, and they need to be the same scale factor. Problem number 22, my radius goes from, I'm going to do the radius and the height. Compare those two measurements. So in my small figure, my radius is 9, my height is 12, and then in the large figure, my radius is 15, and my height is 20. And really, I probably